I think we can start. So hi everyone again, and welcome to the Grammarly Meetup. My name is Ostap. I'm a software engineer at Web Editor team, and I will be moderating tonight's meetup. If you're curious what my team is doing, we are working on adding new features to app.grammarly.com, participating in whole other Grammarly products like iPad Editor, Desktop Editor for macOS and Windows, and Help UI Foundations team, and so on and so on. Grammarly meetups are intended as an opportunity for you to connect with new interesting people. During the talk, you are welcome to add questions to a Q&A panel, and I will announce them. After the talk and Q&A session, we are inviting you to a different Zoom calls to chat with in a smaller groups. You will have a chance to chat with our speaker Nick and Grammarly engineers who are creating our product offerings for web, desktop, mobile, and also other folks from the community. The links to these calls you will find in your registration confirmation, and we will post them, of course, into Zoom chat as well. So you're welcome and encouraged to talk to each other. Let's now get to the main part of today's meetup. We are delighted to introduce our speaker, Nick Sorrentino, Director of Engineering at Grammarly. Nick leads interfaces engineering at Grammarly and started his career as designer and has since spent time in several different roles. Before Grammarly, Nick led an engineering teams and built the core guest experience in Airbnb. So let's welcome Nick.
Great. Thanks for the introduction. It's great to be here, and I'm looking forward to chatting with some of you in the networking event. So throughout this talk, feel free just to add questions, and I'm going to pause a few spots for us to go over those questions. All right, so we're going to be talking about scaling front-end platforms. So Ostap gave a great introduction. I'll just kind of dive into this a little bit more. I lead interfaces and growth at Grammarly. Interfaces is all of our front-end products, our editor, our extension, our mobile keyboards, our Office add-in, and a few other ones that we have coming soon. And then our growth team is really about bringing new users to our product, retaining them. They're responsible for the Grammarly.com product as well. So before, yes, as mentioned, I worked at Airbnb. I did also a few really early stage startups. I got my degree from university in art and design and actually started out doing web and Flash development. For those of you who ever did some of that, it was fun days with ActionScript. For about 10 years, I did some consulting work on the side. Given kind of my background in design, marketing, engineering, I was able to kind of be a one-stop shop for a lot of companies. And well, majority of my career I've spent now in engineering. I've actually held roles and filled gaps in product roles, design roles, data science, marketing, and in sales, actually. So a couple of things relevant to the talk today is actually I worked at two companies that I think that would really relevant to this. First is Metavine. My team built this end-to-end application system for allows other people to build end-to-end application without writing a line of code. So this is connecting kind of databases, APIs, backends, all the way to generating front ends. A lot of large enterprise companies use this, including a couple banks. And then at Airbnb, towards the end, I was responsible for the whole booking flow of Airbnb, but I spent most of my time on the search team. The search product actually received contributions from more than 200 engineers and 30 designers, but it was managed just by my team of about 20 engineers and 2 designers. So before we kind of dive into how the front-end platforms scale, let's talk about how the product companies often scale. This might be familiar to you, but if you kind of haven't not worked at a direct product company, this might be a little bit new as well. So, product gets started, everyone's kind of working on all the same thing. You maybe have a couple backend engineers, depending on what your product is. You'll have, Android, iOS engineers, web engineers. Your team starts really close-knit. The company starts to grow. At some point, you need to break into teams just because it would be too much. And since the company's probably still early on, very technology focused, it might kind of be split into teams based on technologies, such as a backend team, a mobile team, and a web team. But then the company continues to grow further, and then companies do this a few different ways. So sometimes they create teams around goals or outcomes, and sometimes around services. So in this example I put is you might have the growth team, you might have the search team, you might have the payments team, and you might still actually have these front end teams that I've talked about to kind of make sure the kind of core front end experience is still working. But you might have a few front end engineers embedded on those teams as well. And then over time, more and more teams are added, and then your backend systems start having availability issues, scaling issues. How much time engineers are actually writing code becomes an issue, and so you end up creating a whole infrastructure org. And this largely is filled with people with kind of backend experience, and rarely, kind of when this happens, are there a lot of front end infrastructure. So kind of what I've recognized a few times is that companies put a lot of time into their backend infrastructure while their front ends become fragile. And this becomes the bottleneck for product development. So you grow. Now your systems become much more stable because of this infrastructure. Maybe your developer experience has improved, but you're not shipping features nearly as fast, and this becomes a problem. And through those phases of growth, a few problems come up that I've seen. So even as you start to create all of these outcome teams, they end up creating a significant number of dependencies for your kind of core front end teams to be implementing features, and this becomes a bottleneck. The marketing team also starts creating a lot of dependencies on your front end teams, and what happens is they say like, hey, we need to do promos for cross sells and things like this. And what might happen is if this gets sprinkled around to a lot of different front end engineers, what could happen is next thing you know is that 4 banners are being shown to a single user just because it was implemented by 4 engineers that didn't know about each other's work. And the university spent a lot of time, training engineers, kind of more on the back end side. There's some universities are actually starting to spend time on the front end side, but there's far more back end engineers out there than there are front end engineers. So just the pace that you're able to hire front end engineers is just not nearly as fast as you can hire back end engineers. And then, so when you start to create these teams that are responsible for goals and outcomes, you're going to do a lot of experimentation. And with that experimentation, you end up creating forking logic in your code. This actually increases your code complexity and then causes incidents. So now your code has more different paths it can go down, being managed by more people. And then the kind of the paths that a single point in code could get to could be difficult for someone to reason about, especially if they're working on a small piece. And then outages can happen. And then as all of this code gets added to the system, all the forking into the code happens. This becomes more complex. You have a lot more code, especially on web front ends. The more code, your bundle size increases, and your performance starts to degrade and becomes very slow. And then the other thing that happens is inconsistency between platforms. So, you look at these two designs between mobile and desktop, it might not seem like a big deal, but something that could happen is, right, maybe your mobile team has a few more engineers. The company's moved their branding from yellow to green. Your desktop app hasn't gotten there yet. Now, maybe that color shift is not that big of a deal, but over time, these inconsistencies can become disorienting for users. And it also can just be kind of difficult to reason about if they're even using the same product. So a few solutions to some of these problems. Now, imagine you're building a pet store. I love cats, and I try to make sure I get cats in at least every single one of my presentations. So bear with me if you're more of a dog person. So first is component library. This is also referred to as a design language in many companies as well. So what this is just a common set of components, buttons, fonts, colors in a core library that can be shared. So for example, you might have a product card. You might have this button that I'm showing, and then these fonts. So how does this actually solve problems? There's significantly more productivity here because no longer is the team having to rebuild these components regularly. They can just pull this out of the library and things are good to go. You get design consistency, and you kind of lower that collaboration between design and engineering. So as a product's being ready to ship, if you're using the components off the shelf, that back and forth with design and engineering only needs to happen on the net new things where the components should be locked in and ready to go, making the time to ship much faster. So there's some challenges here. So let's say the design team eventually wants customizations for this. So you start out with a product card, and then you might say, all right, like when something's on sale, like let's make the prices green to show off that it's on sale. And then maybe a designer might say the cats aren't big enough on the cards. We need to see more cat, but let's only do that on the home page. So the next thing you know, okay, let's add an option to the component to make it a full bleed image. And then the company might launch, it's Cat Week. Let's make the cats as big as possible on the product cards. And then you can imagine what is happening here through this process is you might have started off with a simple product card with the simple API. And then maybe for the first two, you might add an option, add green price, add full bleed image. This creates a little bit of kind of extra logic into your component. And then this last one, you're kind of stuck at the point like, okay, should I continue to bloat the component API and add a lot of forking logic within that given component, or should I just build a brand new component? And now the next thing you know, you have two different components altogether. Okay, so one of the next steps I've seen happen is a ServerDriven UI of that component library. So what you do is you define a limited number of components, and then the backend API response describes which component to render in the UI. And each item's properties describe how that component should be displayed. And every front-end client needs to build this in their native language. So you'll have a web implementation, an iOS implementation, Android implementation. Maybe if you have a few other interfaces similar to Grammarly, you'll have those implementations as well. So you might say, this is pretty similar to what I'm doing today, but maybe one of the big differences, I'll show an example, is this is a much more declarative way of having your API. So instead of just sending down results, you're actually sending down from the backend, declaring what the UI should look like. So instead of just maybe since this is a cat website, a list of the cats, this is actually, now you're saying, here's a list of product cards, and maybe there might be promotions in the middle. So one of the things that how this can solve problems is this actually continues to give you that design consistency similar to the component library. And actually, one thing that I've noticed is that actually forces a little bit of better design consistency across the different interfaces, because now you have a backend API response that all your front ends need to respond to. And your backend engineers now are empowered to quickly experiment with the existing UI. And even if you go back to this prior example, kind of imagine an experiment where you have a feed of the cats in here, but then this promo. You can have a bunch of experimentation to figure out where the promo should be on the page to be the most optimal for converting people to find the cats, but also these promos. And this just empowers them to kind of do the placement within the feed versus having to ask a front-end engineer to be constantly moving this around. It makes a lot of content changes and ranking changes very simple. And then it also enables those outcome teams that I described earlier to just autonomously ship features without needing client engineers. And the interesting thing that I've also seen happen here is this provides a solution, even if they want to do something more complex than the component library, it gives them a place to validate an idea, to try an early idea of it. And if they decide like, okay, we need a more custom UI, at least they kind of can get some data on using the existing component library. So there are some challenges here. So oftentimes the outcome teams do want custom components. So run into similar problems that I described in the component library is where you can add options to the existing components, like the with green price, with full bleed. This causes a lot of forking logic, or what happens is new components get created. And then as new components get created, oftentimes, unless someone's digging through the whole library, there can be duplicate components. So you might have started out with a switch case statement, imagine, that just had 10 components, relatively light. Actually, what I had seen this happen is what it started with was 7 components, and it ended up close to 200. Then you can imagine with 200 components, especially on web, your bundle size get very, very large, and you have to kind of come up with a new solution to be loading your UI. And so then this proliferation of all these new product features can make tracking and testing much more difficult. The other challenge here is that like net new features can take a little bit longer in this approach, since you actually need to make sure you have a backend response that matches what the front end is going to need. And when you add a small feature, you need to then add it both to the backend and to the front end. Okay, so then imagine you take server-driven UI even a step further. So this is what I call server-driven UI primitives. This is just primitive components that can be composed on the server. So imagine instead of it now a product card or a promo, you're actually just containers, text, buttons, links, spacing. And so you move the layout of the components to the server versus being on the front end. And those primitives have a lot of options on how to display. So what this does is actually enables a lot more customization without needing to compose new components. And it reduces that component proliferation problem that I was talking about. And you get a lot of the design consistency benefits. So here's an example. So now we have the same product card I've been using as an example. Instead of it being a card, it's just a container that has a shadow. There's some spacing on it, and it has a link to where it would go. But then it has some children inside. So it has an image talking about the aspect ratio it's in, what its layout looks like. It'll have, instead of it kind of defining it as a title, this is just text with some font sizes, some font styles. Same thing with the subtext. And then the price is purely just a red-aligned piece of text. And this is a simplification of what this could be. And you can imagine how this could go a lot further with this. One of the challenges here is this is pretty complex to maintain. And the consistency between clients can be complex to maintain as well. At least when you're working with the component library, you could say, okay, it's a product card on web, different than the one on iOS, different Android. But if, let's say, just the container now has changed, now all your components look slightly different. And if there's just a slight difference in maybe the spacing or the rounding of the corners, things like that, that inconsistency can be a little bit harder to find. And the other thing is that your backend engineers, if they're now doing a lot of your layouts, that's not something that they have maybe spent as much time, and they're less familiar with working on UI layout. A lot of front-end engineers spent a lot of their career kind of like working back and forth with designers. So this will be a new experience for the backend engineers, for at least some of the backend engineers. And as you probably saw in this previous example, your API responses can be significantly larger with this approach, which from when you worry about performance, that has some impact on transfer time. All right, then there's actually taking this server-driven approach to even a content management system, sometimes referred to as a CMS. This is a tool that enables non-engineers to render UI and product. You limit this to just a small number of the core components, and you give just some basic user targeting logic. The good thing here is that this actually can improve productivity for your engineering team. You offload work from the engineering, and you empower the marketing team to add some feature sets to the product. So here's an example of what this could look like. Let's say that promo I showed before. You could say, oh, I'm going to target all new users that we have identified as cat owners. The type of item here is a promo, and you could fill out the title, the button text, where the button would go, and some color schemes. And now that this can render in the UI this way. So there's some challenges here. Sometimes for like really big marketing pushes, the marketing team might want something much more bespoke and kind of custom to that campaign they're launching. So the CMS might not support this. This is great for smaller kind of campaigns, but for something larger, usually you need to do something custom. The other downside here is that no given page or feed is actually deterministic or unit testable, because Now you have some logic built into your CMS, you have some built into code, and maybe you have a ranking system as well that kind of is working all this together. It's just, this becomes much more difficult to say this is what this page looks like at a given moment. Of course, then that will make your debugging process much more difficult. And I definitely wouldn't recommend going down this approach until you have very precise component level tracking to make sure you actually can understand how often these components are have an impressions on the users, how often they're being clicked, so you can know the performance of adding these features. And then the last one here is the plugin system. So what this is an ability for engineers to contribute to the UI in a sandbox. So contribute to that feed that I've been talking about, but it's in a kind of a shelter way, because if you kind of give people access to everything, you're very likely to open up the system to incidents. So you provide a sandbox that gives access to tracking for free, give some methods for interactions with other parts of the page, but in a very safe way. And then you also have access to the design language to compose your components. And then when I've seen this work in the past is actually, you're going to proliferate a lot of components through this approach. So then you make a solution to only load the front end component when the component is on the page and in view. So how this actually solves some problems is, if you have a company that's kind of constantly adding new designs and new components, it just empowers that custom component design. But it does it in a way that's much safer. So kind of say, we're no longer going to try to lock down to the 10 or less components. We're going to allow everyone to build a lot, and you create those standards, and then you still get the same performance benefits by only loading the components that are on the page. So what this would look like here is, and there's a lot that goes into this, so I'm going to just keep this somewhat high level, and maybe I can try to answer some questions on this later too. So imagine in your dev environment, you might say, run a command like add new component. It'll say, what card do you want? You're like, I want the full bleed kitty card. You say, like, what systems do you want to run this on? Web, iOS, Android. You want to run it on all. And then it scaffolds out kind of all the files you need. And then if you're taking a server-driven approach in parallel with this, you can now simplify your API responses. Just say, I want to load that full bleed kitty card. Of course, this could have a lot of other structure on top of this as well. And when I had built a system like this in the past, it did. But this is kind of a simplification of what this could look like. So challenges here is through this process, you're definitely going to get duplication of components. And if you're going to build a system like this, it actually needs to be managed by a central team. This is not something I recommend doing until it was going to be owned by a central team. And similar to the CMS as well, you need to make sure your alerting and monitoring is robust. When I've seen this work in the past is actually kind of set up the component level error tracking, click tracking, and then the items that were added through the plugin system could automatically be turned off once they hit a certain error threshold or engagement threshold. Just to recap, there's a lot of things there. We had component library, server-driven UI, a couple approaches there, content management system, and a plugin system. And so what I've found is that a combination of these approaches actually is the most successful. Not a single one is actually the solution. And I think it also varies from company to company. So put together this table of when I thought these things work well. So for your component library, I recommend just doing this after your company gets to a certain size. Kind of once you probably have more than 10 front-end engineers, this is probably something that could actually make sense even early on. But keep it low level. I would never go at a higher fidelity than like maybe something like a product card, because you'll end up having too many customizations to it and it won't become very manageable. Server-driven UI, I'd use it for all stable UI features. Kind of think about your front-end team now creating capabilities that then the back-end teams can experiment with. So this is an area where you have stable UI features that have just like heavy content and ranking experimentation to empower other parts of the company to get learnings easy. Content management systems are great for promotion systems where marketing needs to be doing advertising. I wouldn't ever recommend going to this for your whole entire product unless unless that was kind of the core kind of goal that you're trying to do. And lastly, plugins is like, if you have a company that's a high amount of design complexity, that you're kind of everything's very, very custom, then plugins is a great solution to that problem. I'm gonna pause here. I think there's a couple questions, so yeah, fire away.
Yeah, I will speak them. Like the first one is from Dave. How do you track or audit different versions of the same component being used through the different product teams?
How do you track the same component being used by different product teams?
Yep.
So a couple ways that I've seen this work in the past is the kind of, if it's the different teams are kind of owning different pages of the products, then you have kind of the page that the component's being loaded on being tracked in the impression. So that way you can start splitting your tracking per impression. There's also the other way is that sometimes the API actually requires a field of where it's being implemented, so that can be added to the tracking. And this is benefit both for the team using it, because then they can filter to their usage, and this is also a benefit to the team managing it, because they can understand all the kind of call points of it.
Thanks. Another question from Dave. Do you find a backend driven content API makes A/B testing easier?
In my experience, it made A/B testing significantly easier. I mean, your mobile clients, even if you kind of have a pretty good cadence, are only shipping weekly. It's kind of same with a lot of native products as well, like the native desktop products. So you can do a lot of like rapid experimentation. Some of the other companies I worked at, we even did experiments just for a day or two. And you can and just keep testing things, especially smaller content changes or button placements. So I found that to make it a lot easier on that front. Maybe really, really large, big redesigns, certainly that will not be easier in this approach.
Thanks. And one more question. For all other, we will talk after the talk during QA session. So from Ravjan, would not combining primitive components result in more custom components with possible composition complexities, like 40 ways to combine 20 components?
Yeah, I mean, yes, that definitely can happen, and that's why kind of the primitives you have to keep relatively limited. And what, at least how I've seen this evolve over time, is then the kind of, maybe if there's a few primitives that make a product card, you end up making kind of methods on the back end. You make a product card method, which then puts together these primitives, and kind of that complexity gets managed there. The benefit is now this complexity is managed in a single place in the back end versus being in multiple front ends.
Great. I believe we can continue and answer all other questions after the talk.
Okay, great. All right, so I'm going to shift gears to the path that Grammarly is on here. So first little context is we have a lot of different interfaces, more so than kind of anywhere else that I've worked. We have our editor, which is both on web, but also have a native desktop version of it. We have the browser extension running on 4 browsers. We have some customizations in a few products like GDocs. We have our Office add-in, which works in Outlook and Word. We have a keyboard that works in iOS and Android, and we also have an iPad app. We have a few other products that will be coming out soon as well. So the complexity of scaling Grammarly's front end is significantly more difficult because we have so many interfaces. And this is something that I got really excited about when joining Grammarly just 6 months ago. It's like, this is a really hard problem to solve. And it's an exciting time through the company's growth to work on this. So maybe talk about where we're at scaling wise. We actually have over 150 engineers. Half of them are in North America, a split between Vancouver and San Francisco. And the other half are in Kyiv, Ukraine. As Grammarly grows, we're actually starting to create teams that to drive specific outcomes, like such as grammar, tone, fluency, and clarity. But recently we actually launched this really cool feature here is like someone might have written a lengthy paragraph of text. We can convert it to a bulleted list. We can bold some of the most important information. And, we have now teams driving these things that are kind of outside the core interfaces team. Now, each one of these features needs to be delivered to all of our interfaces. And we just recently created a UI foundation team in Kyiv. And this is their charter is to simplify the process of adding features consistently to all of our interfaces. So our goal is actually to have every feature be able to launch and deployed to all of our interface as quickly as possible. Hope to at some point is that one of our outcome teams can launch a feature and it's instantly available to all 7 or 8 of our interfaces at the same time. So we're very early in this journey, so I'm going to talk about the things that we're building, and some of these things are very early in the process. And a lot of these things are going to sound pretty familiar to what I talked about in the first part. We're working on a design system or a component library. We have a shared web front-end code base for our suggestion feed, creating some infrastructure to allow external teams to be able to contribute in a more simple way. ServerDriven UI, and an in-product messaging system. So let's dive into each of those. Design system, this is a unified set of components to be shared across all the interfaces. Our designers actually have these components together in Figma. Here's some screenshots I have here to allow them to compose layouts just by pulling these components off the shelf. This allows our engineers to then look at those layouts and be able to compose from using their libraries to pull their components off the shelf to make the layouts much quicker using a consistent design paradigm. A shared code base. We actually have at this point a unified web code base that can be shared across interfaces that utilize web tools. This is currently being used by our browser extension, our editor, and our Office add-in. This is using our design system, but then it's adding all of that functionality that Grammarly offers as well. And the team's actually currently creating some abstractions and simplifications to allow other teams to contribute to this shared code base, but kind of in a sandbox way, similar to some of the ideas that I talked about earlier. So we're starting to look into actually moving more and more of our presentation logic to the back end to reduce redundant work across interfaces. And like I said, maybe at some of the other companies where you have kind of web, iOS, Android, even 3 implementations is a lot. For us now, this is like 7, 8 implementations is a lot. So even just moving simple things to the back end is going to allow for a lot of productivity gains. And this also is going to allow these outcome teams, kind of similar to ones I talked about earlier, are teams that are responsible for maybe clarity or fluency or kind of the takeaways feature I described. They can just launch new features with existing componentry and allow our core front-end teams to work on some other things. And this is, the goal is to enable a lot more feature consistency between mobile, desktop, and web. And then in product messaging, we're actually creating a platform to empower our marketing team to be able to message to our users with announcement or important updates. And now the point here is actually to create a single place to message, to manage messages to our users to avoid over messaging. That problem I described earlier, where if maybe multiple different engineers and different teams are adding these messages, the next thing you know, you can get that banner blindness, which I'm sure you've seen browsing the web before. So kind of create a single place. We can manage the frequency, we can experiment with it, and measure the effectiveness of each message. This currently isn't managed by a CMS, but this is something that we have planned for the future as well. But we are still very early in this plan, and we are looking for talented engineers to help us to build all of this and really scale up our front-end platform. And we're also looking, of course, for talented engineers to work on a lot of the other things that we have going on. So I'm going to pause here for a minute or two, have a QR code if you want to take a look at some of the positions we have open. And we also have a few positions open that I'm happy to talk about in the networking chat that aren't on that site.
if we are waiting, maybe I can ask you some questions from the QA.
Yes, that's the next slide. So let's just go to the questions.
Okay. Okay, yeah. Or you can even stay on this slide, yeah. Okay, so there is a couple of questions about design system, like can you describe the tooling and processes behind your design system? Or I can even describe how it works from the web part.
Great, yeah, you should go for it. I love that.
Yeah, actually, we are using our custom extension for browser and for build process that just grab symbols from the Figma into the code base, like synchronize through the Figma API. So nothing fancy there. As I even can remember, there is some open source tooling for that also now. Okay, so the next question, like, there are too many. Would not CMS result in more load on UI engineers to support the CMS?
Sorry, could you repeat the question?
Would not CMS result in more load on UI engineers to support the CMS?
So it depends. It depends on kind of what what the situation is. So, and this is the reason why I recommend this largely for promotion systems that kind of have more of a kind of singular design, because it's not always the best use of the engineer's time to build new promotions every single week. So if you can find a way to make that simpler and have that managed by a CMS for just a few promotions that can be rotated out, that is great. Empower like that targeting to be done in the CMS. But if kind of each week you're doing something custom, then yeah, the CMS is not a good solution. So I would say for things that are relatively stable, that kind of managing that complexity of owning the CMS and the UI to render it is worthwhile if your team is doing a lot of kind of like repetitive type of marketing with similar styles.
Thanks. Another question is, you had mentioned the plugin system would need a core team to maintain and or building it. What about the other systems? What's the approach to building them if there is no core team who owns them?
I would say, I mean, in all of the examples that I gave, having a core team own them is a much preferred approach. I would say the complexity of a system like the plugin system makes it absolutely imperative. I've actually seen companies get by like with a component library that's somewhat distributed. Maybe you'll have a couple engineers and maybe a designer or two own it, and it's not like kind of a core ownership. But definitely recommended after you get to a certain scale, and actually when you're at even Grammarly scale, you have a core team own it. And we have our UI Foundation team to own some of these things as well.
There is also an interesting question, like, have you considered using some of the existing tools for server-driven UI by Airbnb, Facebook, Tumblr, etc.?
Have we considered using those? I actually...
Like, do you know about some existing tools? There are a couple of questions for server-driven UI. Maybe like you heard about them.
I don't think, I mean, I haven't seen any kind of tools that make that. I mean, there's some things that making like not directly correlated to server-driven UI, but yeah, I might need kind of more of a specific if there's a specific tool. But I would say, and even the thing that we built at Airbnb, because my team was the team that built the system for server-driven UI at Airbnb, that was all kind of custom work and we didn't use any open source tooling because just the needs for each company are pretty unique. But yeah, if there's something specific, I'd probably be happy to talk about that.
Yeah, actually, for me also, I did not heard about any like frameworks for server-driven UI that you described. Yeah, okay. Okay. Actually, there are a lot of questions that I believe we can talk in our networking chats in Zoom, like with our front-end engineers, iOS engineers, and so on, since they are just directly related to how Grammarly delivers features and so on and so on and so on.
Okay, so just wanted to put this up here too. And feel free to reach out to me directly. I'm more than happy to answer questions. You can shoot me an email, connect with me on LinkedIn. Happy to talk about opportunities we have open in the company. I'm happy to talk about any of the content of this. So feel free to reach out. I look forward to chatting with you.
Yeah, thank you so much, Nick.